Board. Good morning. By the way, how was the quiz yesterday? Not too bad? Any comments?
I mean, I didn't think it was like very hard, but I mean, there was a few moments where I kind of had to double check my answers just to make sure I was doing the right thing.
Yeah, and I want you guys to hear this. Hear me say this. I understand, we understand what the situation is. We do understand what the situation is. So we went over the entire review sheet, and I know I didn't upload the answers, but you always could have gone back to watch the video. So watch how it works and then apply that. So it was very similar to your review, obviously different numbers. So make sure you guys understand how to apply it. That's also part of the reason we only give you guys like 24 hours to turn it in. Is can you do something in the crunch, in a timeline, where you guys have about 12 hours or so to get this done. So you should be able to do it on your own, but just in case you can't, you've got your own notes to go back and do this. So hopefully you all included, I haven't even opened up the PDF yet. Hopefully you guys all included your work. Like I said, if you didn't show your work, you're not going to get any credit for this. It is simply too easy to cheat. And remember, they just passed this last night. I don't know when we're coming back, but they just approved a plan for when we're coming back, in which case we will most likely have finals. So you're going to see this all again. And if that's the case, remember your finals are going to be 20% of your grade. Not trying to scare you, just letting you know that you might have a friend that's giving you some answers, and that might help your grade for now, but it's not going to help you learn this. And by the way, everything we do in here, you will see again, almost everything you'll see on the ACT or SAT. All right. Now, let's go ahead and get started. I hope it wasn't too bad. I never want to trick you. That's just the stuff that you need to know. Sorry, we're on the wrong slide. That's for my other class. That's for tomorrow. There we go. So we are talking about transformations. If you guys remember this from last year, the transformation is always the same, no matter which form it is. And we're just going to study 3 or 4 different forms today, and we've only got about a half hour to do it. So we are out of here at 10:22, so we've got exactly a half hour to do this. Now, when I say the parent function, that is the most stripped down basic form of the function possible. Examples of parent functions, and if I start going too quick, are this. Let me know. Y equals x. Y equals the absolute value of x. Y equals x squared. Y equals the square root of x. These are all examples of parent functions because nothing else is happening to them. They're not being moved, they're not being shifted, they're not being stretched, they're not being flipped. They all go through the origin. Now, you're not always going to see it y equals. It could be written like this. F of x equals, which means the same thing. One other thing, so now that we've shown you guys several parent functions, let me just show you a very quick example of how this could be stretched, shifted, whatever. So y equals 2x plus 3. This is the parent function. This one's been stretched or moved. If I've got y equals the absolute value of x, here's an example of a stretch or a shift or whatever. That's it. So we take the parent function and we're just kind of shifting it. Now, when I say we're going to get kind of mathy, all this stuff here is mathy. And that means we stay unclear. It's written in a form that's not just plain English. It's hard to read what this even is. So listen to how I say this because this is the entire heart of the lesson. Then we're just going to go through and apply it. Whatever goes with your x value. If you know in a graph that this is your x-axis and that's your y-axis, x always shifts something left or right. So your h value is how far it's moving left or right, always. Now here's a heads up. So if you don't pay attention to anything else, here's the number one thing you hear today, so please listen. Your vertex or how it's shifting is always going to be the opposite of h. And I'll explain why here in 1 second. If your vertex is going to be the point hk, it is always the opposite of h. And here's why. Because the question we're really asking is, what value of x would make the whole quantity equal 0? For instance, if I have something like this, I would say that this is being shifted right 2. Why is it right 2? Because what value of x would make the whole quantity equal 0? Positive 2. Does that make sense? So my vertex on this would be positive 2, positive 3. So it's always going to be the opposite of what's happening to x, and your k value, which moves it up or down, it is what it says it is. Again, the simple explanation is this. If x equals 2, 2 minus 2 is 0, and 0 plus 3 means that y is 3. So that's it. I'll say it one more time. It is the opposite of what's happening to x, and your k value is what it says it is. Any questions? Now again, these are ambiguous formulas, just showing you what's happening. So it can be written with y equals or function form, but again, the x moves it left or right, so that moves it left or right. The k moves it up or down. So this a does two different things. First of all, ignore the plus or minus for right now. A either stretches this or compresses it. A stretch is kind of like a rubber band. Well, if I take a rubber band and I stretch, I pull it down really far, the sides actually get closer together. That's a stretch. A shrink, imagine again, if I kind of push down on the rubber band, what happens? A shrink, it's going to go out wider. Now, I said shrink, that's really a compression. Those words are pretty much interchangeable. In Algebra 2, we called them shrinks. Now we're calling them compressions. Now, again, please listen because I didn't write this down. That's not what I wanted to do at all. If, and I'm going to say the absolute value here, the absolute value of A is greater than 1, it's a stretch. The absolute value of A is less than 1, it's a compression or a shrink. Now, people get caught up on that whole absolute value thing. You know how about 2 minutes ago I told you to ignore this? I still want you to ignore it. So if A, basically, if it's greater than 1, it's going to be a stretch. If it's less than 1, it's going to be a shrink. If it's positive, it has to open up, and you'll understand what I mean. If it's positive, it has to open up. If my parent function is this, y equals x, has a positive slope. If it were x squared, it opens like this. Now, if it's negative, all the negative means is a reflection. If that's negative, it is being reflected over the x-axis. Well, that's real simple. If this is being reflected over the x-axis, the straight line, now it's got a negative slope. That's being reflected, now it opens down. If I have something like this, now it's being reflected, now it's gonna open like this. If I have something that looks like this, and it's being reflected, it will now look like this. And we'll talk about that even more. So if it's negative, that means a reflection over the x-axis. Any questions so far? By the way, you can do most of this stuff on your calculator. You'll still need to know how to read it. So if you ever get to something where I ask you to graph and you really have completely forgotten how to do this, you can do about 95% of it just on your calculator. So let's talk about square roots first. Again, your notes have already been uploaded to Canvas. And I'm going to upload this video to Canvas as soon as we're done. But let's start by showing you the parent function. If you ever forget what this looks like, and most of you probably do, you could always make a table. Now, I am not suggesting that you do that, but if you get to a standardized test or anything where you have to graph and you completely forget, and trust me, it happens to the best of us. Just make a table and plug in some values. And the 5 values I always plug in are very simple and make sense of it. Now I'm going to show you how to do this on your calculator here in 1 second. But if I plug in -2 for x, y equals the square root of -2, what's my problem with that?
You can't square root a negative.
Exactly. So that's undefined, so that actually doesn't have a value. Same thing with -1, doesn't have a value. Now somebody's going to say, and I say doesn't have a value, doesn't have a real value. I'm surprised nobody said, what about I? Which we'll get to soon. But the square root of 0 is just 0. The square root of 1 is 1. Square root of 2 is, I don't know. Let's keep going though. Square root of 4 is 2. Now I have some points I can do, or I can use. So x cannot be negative, and that's talking about domain and range, which we'll get into tomorrow. So the lowest this can be is 0. When x is 1, y is 1. When x is 4, y is 2, so on and so forth. So that's what your parent function looks like. Any questions about that? The biggest thing that you guys can do are know the rules for A, H, and K and what the parent function looks like. Now, if I had something in here for H or for K, it's literally just going to move this. For instance, if I were graphing this, how has this graph been shifted? What do you think that's done to it?
Left 3.
Exactly. And if it's outside, what's done here?
Up? Down 2?
It's down. So the K value says exactly what it says it's going to do. So I would move all of these points left 1, 2, 3, down 2. Left 1, 2, 3, down 2. Left 1, 2, 3, down 2. And you get the exact same drawing. Any questions? All right. Let's very quickly, and I don't know if we'll get through this whole thing today. Let's very quickly talk about how A affects it. What if I had something like this? Y equals 2 times the absolute value of X. And I'm going to switch to pink to light blue. This is taking each one of these values times 2. So once you've got these inputs here, well, I still can't have negatives under the radical. 2 times 0 is still 0. Square root of 1 is 1, times 2 would be 2. If I plugged in 4, square root of 4 is 2, times 2 is 4. So you're literally multiplying all of your outputs by this value. So it would be 0 when x is 1, now it's 2. When x is 4, now I've got 4, so on and so forth. So that's what a stretch looks like. It goes up much quicker. So just for good measure, I'll use green here, if it were -2, then I would multiply all of those values by -2. So what happens? Now I've got the point 1, -2, and 4, -4. And it looks just like this. So these aren't really even rules you have to remember, but it will behoove you to kind of memorize some of that stuff. Any questions? All right. Either I'm a really good teacher, you guys understand this, or I got people not really paying attention. Not really sure which one it is. Take a second and try these on your own. Sorry, I just want to make sure I haven't missed anybody. Is Michael Calix, is he on here? Or Kayla, or Sierra, or Tanny, or Robert? Okay, got everybody else. All right, and we're out of here in about 13 minutes. So if you know what the parent function looks like, I'm going to go ahead and do number 1. So again, 0, 0, I plug in 1, 1, plug in 4. I'm putting the parent function up right away. So if you know that this is what the parent function looks like, now you can kind of do this on your own without anything else. By the way, this will be faster to do it this way than using your calculator. And actually, you're less likely to make a mistake doing it this instead of the calculator. So what's happened, all of these points have been moved left 4 and down 2. So each one of the points left 4, down 2. That's my new vertex. Left 4, down 2. Left 4, down 2. And that's what I get. Now, I do not mind if you put the parent function up there as long as you show me. Yeah, as long as you show me that this is the one that's your final answer. By the way, if you want to make a table by all means. So here, again, you know that you can't have negatives under the radical. So I'm going to start, I wrote 0. So I'm going to start with 0, and then I'm going to put in perfect square. So 0, 1, 4, that's good enough. Well, initially, if I plug in 0, I get 0. 0 plus 3 is going to be 3. If I plug in 1, square root of 1 is 1 times negative 2. Negative 2 plus 3 is 1. If I plug in 4, square root of 4 is 2 times negative 2 is negative 4 plus 3 is negative 1. So 0, 3, 1, 1, 4, negative 1.
Did you say it won't work in your calculator, or?
It will work, but here's what I'm worried about. Sorry. All right, so if you're plugging it in your calculator, let me pin my video here real quick. So if I go to y equals in my calculator, I have to hit negative 2 square root of x, so second x squared. X is in between the alpha. People make a lot more mistakes actually on the calculator than they do by hand. You see how that arrow is still underneath the radical? Well, the plus 3 was on the outside. So I have to hit over and then plus 3. When I graph it, that's what I got. Now, if I ask you for points, what are those points, those exact points? Because people won't quite understand that. The exact points are this. It's second graph, that's your table, and then I could use these points. So there's nothing wrong with using your calculator. The problem is you still have to know how to use your calculator, and I'm still going to ask you to describe the transformation. So there's those points at 0, 3, at 1, 1, and somebody's going to say, well, what if it was less than 0? Ooh, we get an error, which means it's restricted. Why? Because you can't have a negative under a radical. Remember that. We're going to talk about that much more tomorrow. Let's go back and let's do it again.
So 0, 1, 4 will always be your starting points?
Be careful with that. If it's just the square root of x, yes, 0, 1, 4 is always what I want. Why? Because those are perfect squares. But I want you to pay attention to this, because if you're making your table, now I don't want to just start with 0. I want to start with the value that makes the whole thing 0. So makes the entire radical 0. So I would start with negative 4. Because negative 4 plus 4 is 0, negative 2. And that's my vertex. So negative 4, negative 2. And that's why it's important to know the shift. Does that make sense? I can't start with negative 5 because this whole thing would be negative. I don't want to start with 0 because that doesn't show me my vertex. So you always, always, always want to start with your vertex. And from there, it's fine. Do whatever. So from negative 4, well, the next perfect square is 1, right? So what could I plug in for x to make this whole thing equal 1? And the answer is negative 3. Negative 3 plus 4 is 1. Square root of 1 is 1. Minus 2 is negative 1. My next perfect square is 4. So what could I plug in for x to get 4? 0. So 0 plus 4 is 4, square root of 4 is 2, 2 minus 2 is 0, and that's where we come up with those points. Again, it is easier to think of them as know the vertex and then know the shifts and transformations, know how this works. Now, and I'm not going to drill you guys on all of this stuff. I basically want you to come up with the vertex and a couple points. Absolute values. If anybody had me in Algebra 2, you know that absolute values make V's. So it either makes a V like this, or it makes a V like this. Again, it opens up if A is positive, and it opens down if A is negative. Your vertex still, H moves it left or right, K moves it up or down. So absolute value of X, make a table. So -2, -1, 0, 1, 2. Absolute values always come out to be positive. So if I plugged in -2, the absolute value of -2 is 2, -1 is 1, 0, 1, 2. And it looks just like that. Now we're running out of time. I thought we'd be able to do some more of this stuff. But basically, here's all you need to know. Same thing. If I have the absolute value of X plus 1 plus 2, what's that plus 1 doing to it?
To the right one.
Wait, it's always the opposite. So it would
Should
be
got left one.
to the left one. That's all right. And that's part of the reason I'm asking you guys this. It's always the opposite of what's happening to X, always. And then your K value is what it is, which is up 2. So every single one of these points would be left 1, up 2. And then the rate of change stays the same. So notice it went up and over, up and over. Yeah, I just didn't do that very well. You can see I did a much better job graphing the right side than the left side. That's it. All right. So absolute values make V's. So you guys don't even have to graph this, but let's just see what this looks like. What's my vertex here on this first one? This is moved at how?
Left 3.
So left 3. And what do you think this -3 does?
Compresses it.
So because it's greater than 1, don't worry about the negative. Because it's greater than 1, or is greater than 1, it stretches it. It only compresses it if it were a fraction. If that were like a 1/3, that would be a compression, which means it's going to be wider. This is going to be more steep. And what do you think the negative does?
Flips it upside down on the on the X
Down.
axis.
And I actually have no problem with how Tate just said that. It flips it upside down. It's a reflection over the x-axis. So if you know your vertex, so my vertex is going to be -3, 0, -3, 0. Then apply your slope. So if it was up 1, 2, 3, and over 1, now it's going to be down 1, 2, 3, and over 1. 1, 2, 3, over 1. Now, we do not expect you guys to memorize what everything, how it all behaves. We want you to know the parent functions and how H and K and A affect it. So at the very least, you should be able to describe it and then kind of slop something up there. Real quick, what's your vertex on the second one?
Three, one.
There you go. It's positive 3, 1, which means my parent function has moved right 3 up 1. So right 3 up 1. Again, my a value is positive 1. So it's going to look like this. Let me see. We have too much left to do tonight. So luckily you don't have any homework tonight, but we will finish this slide tomorrow and get in as much of the domain and range as we can tomorrow. Okay. So we will be finished right there. Ignore your homework on big ideas. Ignore your homework on Canvas. That will be assigned tomorrow. If you want to look at it and try it, feel free. It's only 6 questions anyway. Other than that, we are finished. All right. So you guys, if you'd like to, you can go ahead and